Explain why that surface area is infinite. All right. Well, the area would be 2 pi, 1 to infinity, the function, times root 1 plus the derivative of the function. Bring down the power, reduce the power by 1. Okay. So that's 2 pi, 1 to infinity, root 1 over x squared plus 1 over x4. No, let's try this. Hang on. X power minus 1 root 1 plus x power minus 2 the x. Okay, bring down the power, reduce the power by 1. Maybe no. Maybe I should put this as a root and x squared plus 1 dx. So then that becomes 2 pi, integrate 1 to infinity, 1 over x squared, root 1 plus x squared dx. Pay down the power, reduce the power by 1. Bring down the power. A substitution is here, maybe. Why don't I try u equals x squared? So du dx equals 2x. So this becomes 2 pi, 1 to infinity, 1 over u, root 1 plus u, and then the dx is a half du. And there's an x here, which is a root u. And then that could cancel with that to make it that. So 2 pi root 1 plus u over u du. 2 pi do I want to say root 1 plus 1 over u du? U is, oh, it's still 1 to infinity, actually. U is decreasing down. Maybe I could use some kind of inequality here. Actually, maybe maybe I could say that this would be bigger than or equal to 2 pi 1 to infinity. And I could make this smaller, so it'd be 1 over x squared dx. No, that's finite. It's not quite right. Oh, it would be bigger than root x squared over x squared. If I drop the 1 here, I've made it smaller, so it has to be bigger than that, which is equal to 2 pi, and that's going to be an x. So it's 1 over x dx. So that's equal to 2 pi log x 1 to infinity. And the 1 is 0. So it's 2 pi log infinity, basically. So the area has to be, well, I know it's not going to be equal, actually. The area has to be more than infinity. Okay. So that proves the first part. But the volume, okay, well, the volume would be 1 to infinity f of x squared. Now, by the way, that substitution I did there, or that's inequality I did there, that's because root 1 plus x squared is, or rather I should perhaps say, x squared is smaller than 1 plus x squared. So I've made all of this smaller, and it's also all positive as well. So that's why I could do that. Now let's look at the volume. Integration the function squared. So that's increase the power by 1, divide by the new power. Put in infinity and I get 0. Oh yeah, let's not forget the pi. Put in the infinity, that's 0. Put in the 1, and that would be 1. So the volume is pi, which is finite. Okay, so I think the only trick here is just that inequality there. But I wonder if I can get the integral here. Let's put the limits in. Yeah, infinity plus 2, but you can get this log formula here, so it is possible to integrate this exactly. But I don't think it's necessary because the infinite limit is enough just to show that a lower bound diverges 2.